Hello everyone, we're going to try number 2 here. This is a lot less stable than I expected, but hopefully you can see everything, and you have this in front of you, so that's good. Um, so this is Circuits 1, Page 1, problem number 2. And before I get started here, let me introduce you to my lab assistant. Hello, Francis. Because she's begetting like that, I can do this. Also, because normally, if you were to listen here in the house, you would probably be thinking it's a war zone because Westerns 24/7. But it's quiet. So, we're going to find the total resistance, which means we're going to simplify this down into a single equivalent resistor. All right, so the idea is we're going to combine pieces up. The idea is that combine things in series, combine things in parallel, and then combined all the other. And you notice it's both series and parallel, and it's all mixed up. So we're going to do it the simplest bit that we can, and we'll talk about our reasoning there. Then we'll find a total current because we'll have one battery and one resistor, one equivalent resistor, and so we'll have a total current. And then we're going to go through and find the voltage on each of these things so that we can find what's going on with this thing. And so you can imagine this is a circuit you have and you're trying to solve some problem. Like this thing keeps blowing up and you want to know why. So that's what we're going to do. And we're just going to sketch it out on paper. And so that's what you should do when you're trying to do this, is often sketch this out if you can't quite hold on to everything all at once. So, clean sheet of paper, and I have 20 volts, and there's my 30 ohms, and my apologies for potato vision, 60 ohms, 15 ohms, and that closes that part of the circuit. And then we have the 25 ohms. And I want y'all to remember from when we did the first problem that you're going to have V equals I R, and you're going to have the circuit, the resistor rules. In series, it's just R1 plus R2 plus dot dot dot. And in parallel, you have to do 1 over, the parallel is 1 over R1 plus 1 over R2 plus dot dot dot. And so for this, you have to find this right side first, and then you'll have 1 over a number equals some constant, and you invert it. All right, so we'll walk through that again. But this is our circuit. Again, note that it's the same as this one. Sorry for the shadows, but it's the light that I have that works. So we're looking at this and we're thinking, how am I going to do this? What can I add together? What makes sense to add together into simpler equivalent parts? All right, and I say, well, I have this 30 ohm resistor. What can I add to it? I could add the 25. I could add the 60. All right, if I have a choice, then I can't really mess with it. And the reason that I can't mess with it is I don't know what to do with all this stuff. So I look at this stuff and I'm like, well, can I add it? And I have, if it was 60 and 25, I'd know what to do with it. But I have this 15 here, and that's kind of bothering things. So what I'm going to do is ignore the parallel bit, focus on this. This I can add up. 60 and 15, that makes sense. This is just 75 ohms. All right. That's just using the series rule. 60 plus 15 is 75. Now, the next thing I want to do is add up this. And what I'm going to do is re-sketch this diagram. 20 volts, 30 ohms, and the parallel resistance right? That's what I want to get to, because then I can simplify this. This is going to come from the 60 and the 15 haven't been added, and the 25. And so I'm going to try to solve that. I'm going to do 1 over the parallel resistance equals 1 over 25 ohms plus 1 over 75 ohms. Right? So I have that. And then I can do some math here, right? This is 3 over 75. So 1 over the parallel is 4 over 75 ohms. So our parallel is 75 over 4 ohms. And then we can write it out in decimal is 18.75 ohms, right? Just do 75 divided by 4. Right? And so now we know what this is. We can simplify it even further. We can go and say it's just 20 volts. And then it's adding these two. 30 plus 18 is 48.75 ohms. And this we can apply Ohm's law to. Right? V is I times R. So I is V over R. Right? Is 20 volts over 48.75 ohms is 0.41 amps. Right? Check, when you calculate, excuse me,